Okay, now we are going to move into dilations. Now we did translations, rotations, reflections. Those are our rigid motions that keep congruence. You know, if we have a triangle and we do a reflection, a rotation, or a translation, they are the image is going to be congruent to the original. However, with dilations, we know that's not going to be the case. And here's just pictures to show you some examples here. So here's the original picture. This is girl here, and then we can dilate her smaller or larger. If we dilate her by, let's say, a half, okay, she becomes half as big. However, everything is still proportional. She's still proportional. We don't see her head's not like stretched out or like squished, right? Everything's proportional. Everything gets smaller by the same amount. Same thing if we make her larger, right? It's proportional. This, when you do not do everything by the same amount, it's called a stretch. So here's this little boy here holding the football. See how this is a stretch and not a dilation, because see how his head is nice and round, and then all of a sudden it's like that, or like flattened. Okay, and especially in the last picture there, it's really distorted and squished. Okay. So that would be not a dilation. When it's not proportional, when we don't have proportional sides or proportional things going from the pre-image to the image, that is not a dilation. So we need to know the difference between a stretch and a dilation. All right, so now dilations, what we do for dilations is we simply multiply by the same number. The x and y got to be multiplied by the same number. So that's what we're going to be doing. Now, in a stretch, you would multiply the x by one number and the y by some other number. That's a stretch. We don't do stretches, but that's why we should know that when we do a dilation, we multiply everything by the same number. All right, so there's some example with triangles here. See how the triangle's in a dilation? Well, here we go. Here's a stretch, because we're multiplying the x by 1 and the y only gets multiplied by 3. You start with xy, you go to x3y. That is not a dilation. That is a stretch. The y is only getting multiplied by 3, not the x. For a dilation here, this is a dilation because the shape is proportional. The orange one is bigger than the yellow one, but it's the exact same shape, just a bigger size. Same shape, bigger size. See how the yellow and the green here? The yellow one and the green one are different shapes. Okay, I guess they're both triangles, but look at how AC went to DF and stayed exactly the same, but BC got smaller. That can't happen. That cannot happen in a dilation. Everything's got to get bigger or smaller by the same amount. So here's some examples here. Determine whether the following are stretch or dilation. So see how they're both multiplied by the same number? It doesn't matter if it's a radical or whatever number it is. They're multiplied by the same number, so that would be a dilation. See this one here? Look at how it's kind of like, looks like, you can just tell it's stretched out, right? Stretched out vertically. So that is a stretch. And then this one appears to be a dilation. Okay, it's just blown up in this all the same direction, blown up the same way. It's like doubled, for example. Everything got doubled. Okay, so that's a dilation. I think we got that. So again, the coordinate rule for dilation is xy becomes kx ky. If you dilate by k, we're going to call what's called the scale factor. Okay, k is going to be called the scale factor. And again, the scale factor has to remain constant for the entire dilation. Everything gets multiplied by the scale factor, or else it's not a dilation. So if they say big D dilation, O is the center of dilation, typically the origin. If it's not, they'll give you some other point, and then K is the scale factor. So here's some examples of dilations. Dilation about the origin of 5. That just means multiply x and y by 5. Okay, dilation about the origin 1/3. Multiply x and y by 1/3. -3 multiply by -3. A stretch would be this. See? Multiply by 2, multiply by 3. Multiply by 2/3, multiply by 5. X and y multiplied by different numbers. I think we get the idea by now. All right. So, coordinate rules now. So you see how we want to dilate xy from and it's going to be 2x, 2y. So if O is 0, 0, and we multiply by 2, if we take 0, 0, and we multiply by 2, you're still going to get 0, 0. Okay? So O prime is still O. All right? Now C prime, though, C is 1, 3. If we multiply by 2 and multiply by 2, C prime is going to be 2, 6. Multiply by 2, multiply by 2. 2, 6. Right there. 2, 6. 2, 6. That's C prime. So now, see how the object is dilated? It got multiplied by 2. The original segment, I'm going to draw that. The original segment was right here, CO. Now, the segment has doubled in length. See that? It doubled in length. Okay? And here it is right here. Done for us. Boom, boom. It doubled in length. Okay? A key to understanding dilations from the origin is that the coordinates of the point being dilated represent the slope values of the rise and the run. That's what I want you to take a look at here. So, I want to erase that. I'm going to switch to, oh, no, I'm not. All right, so see how the slope of this line, the original, it went from here to here. I'm over here now. It went up 1, 2, 3, and over 1. So the slope is 3 over 1. Well, look what happened when you go from C to C prime. Up 3 over 1. See? Up 3 over 1. The slope is still 3 over 1. You just do the slope again. Slope, slope. You double the slope, basically. Okay? And not that you double the slope. You just perform it again. So we went up 3 over 1, go up 3 over 1. That will double the length of the segment. Okay? It's all about slope. So here we go. Here's one here. Now we want to do a half. So see how the slope, I'm just going to show you how to do it with slope. See how it's up 1, 2, up 1, 2, 3, 4, over 1, 2, 3, 4. Okay? Up 4 over 4. So my slope, remember slope is M. Slope is 4 over 4. Don't reduce it. Keep it 4 over 4. The slope is 4 over 4. If I want to dilate this segment, I'm just going to go up 2 over 2. So I'm going to go up 2, boom, boom, and over 2. Okay? So, I'm sorry, from the center of dilation. I'm sorry. That's wrong. I forget what I just said. From the center, it goes over 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4. So over 6, down 4. Over 6, down 4. Just chop that in half. Okay? So the slope is 6 over 4. So instead of going and just chop that in half, so I'm going to go over 1, 2, 3, and down 2. Okay? So instead of going over 6 and down 4, I'm going over 3 and down 2. So for this one here, for B, this is for A. For B, okay, it goes 1, 2, so I'm going to do a different color. I'll do black. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. It goes 2, 8. So I'm going to go half of that. I'm going to go 1, 4. 1, 2, 3, 4. So all I did is cut the slope from O to A in half and cut the slope from O to B in half. And there is my new line segment. See how it's half? It's shorter by half of AB. This is A prime and this is B prime. Also notice how you can connect O to B and you will go right through B prime, and you can connect O to A and you will go right through A prime. This is half. AB prime is half. And you'll see that done right over here. Okay? So just chop that slope in half from the center and you will get your images. Okay, so now here we're not gonna use a graph, we're just gonna use the rule. If it's a D2, we're just gonna multiply by 2. So -3 is gonna be -6, and then 5 is gonna be 10. and then times 2, 2 times 5 is 10, and then 8 times 5 is 40. Good thing we don't have to graph that, huh? 1/3, 6 times a third of 6 is 2. A third of 24 is 8, so 2 8. 8 1/8 is 1, and then 3/4 times 8 is 24 over 4, which is 6. And then now this is going backwards, so I need to make it so that I multiply by -2 and I get 12. So this is going to be -6. -6 times -2 is 12. You're going backwards now. And then this one needs to be 5, because -2 times 5 is -10. So basically you're dividing instead of multiplying, right? 12 divided by -2 is -6. -10 divided by -2 is 5. And then this one here, 2 times 2.5 is going to be 5. And -4 times 2.5 is going to be -6. All right, -6. So so dilations are simply done by multiplying. If you know the original point and you know the scale factor, that's how you can get the point for the dilation. But now we're going to do when we're not at the origin, and that's going to be the end of our lesson, is doing ones that are not at the origin. Okay, so these are not at the origin. Again, we're going to use the rise and run technique. We're going to use our slope. So see how, now this is dilation T2. So T, oops, I'm right over that there. T is the center of dilation. T is the center of dilation. It's not the origin anymore. It's T. So from T, we are dilating, okay? And notice how the slope is up 1, 2, and over. So it's 1, 2, 1, 2, 3, 4, 5. So it's up 2 over 5. See how the rise over run, we already did that, is 2 over 5. Okay, so now we want to do a 2. K is 2. We want to dilate by 2. That means we want to double the length of our segment. So from T, we go up 2 over 5 and just go up 2 over 5 again. Boom, boom, up 2 over 1, 2, 3, 4, 5. There it is. Okay, I'll make it red. And there it is. That is going to be our image. That is going to be our H prime. Okay, and you could tell that we doubled that length. It was originally TH, and now it's H prime, TH prime. Okay, so we have doubled, and that's that. All right, so now this one here, we want to do a 1/4 about point T. Okay, so T to G is over 1, 2, we want to do the rise first, sorry. So rise, 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 8 over -12. It's up 8, 12 to the left, okay? We want to do from T, right, from T, the K is now 1/4. See how it says D 1/4? So we want to go a quarter of the way, 1/4. So we're just going to go 1/4 of 8, and that's going to be 2, and then 1/4 of 12, and that's going to be -3. So we're going to go up 2, we're going to go up 2, boom, boom, and then we're going to go 3 to the left, boom, 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 and there it is. This is the image G prime. Okay, so TG prime is right there, and that length, that green length, is 1/4 of the length all the way to G. If I went T to G prime is 1/4 of the length. Okay, we just chopped it, both the rise and the run, we chopped them in fourths. Okay, we divided by 4. And that's that. Okay, so we'll practice this in class tomorrow, again, G prime, I should have wrote that. G prime is, we should get the coordinates, 1, 2, 3, 4, 5, 1, 2, 3. So it's going to be at 5, 3. All right, 5, 3 would be the coordinates there. So you don't always have to dilate from the origin. You could dilate from any point. It's just using the slope to chop it down or make it bigger. Okay, we'll see you for more practice on this in class.